you're interested in how the data offline and sync capabilities work in Oracle Mobile Cloud Service, specifically for the client WIN's collision detection and resolution features, this episode is for you. G'day, I'm Chris Muir from the Oracle Mobile Platform team. In the previous episode, we described the three options the client SDK has for resolving conflicts: client wins, server wins, and preserve conflict. As the focus of this episode, we also noted that for the client wins option, that this option states when the client sends an updated object to the server, if the server detects a conflict, in this scenario the client will expect its updated object to override the server's updated object, and the client SDK will retain its copy of the object going forward. So what we want to do is talk about this in a little bit more detail. In order to do this, we need to identify three different scenarios and how this option will be used by the client. The mobile client programmer in code can either create a new object to sync with MCS, or if a record has already been synced from MCS, the objects can be updated, or alternatively, it can be deleted. These represent the three scenarios. In using the endpoint API to do this, the endpoint API will either send a REST post, put, or delete to the server-side custom API based on what the client does. From here, the server-side programmer will write node code to act upon the post, put, or delete request and send a response back to the client, with maybe a 200 series success status code or possibly 400 series error status code. But to emphasize, overall, there are three scenarios we need to consider: create, update, and delete. So let's consider now the create scenario when using client wins. In this scenario, the client-side programmer is not working with an existing case object on the client. Rather, they are creating a new object on the client using the MCS endpoint API. So they first fetch the endpoint, then create an object, and finally call the save function. Thanks to these operations, the endpoint API will send a post call to MCS to the identified collection through the URI and the new object as a payload. In this case, the server-side programmer must accept the new object and save it somewhere, possibly in the storage API, the database API, or to a remote service. Remember, MCS is very flexible. In doing so, depending on where the object is stored, the custom API code needs to retrieve or generate a new object ID for the new object, and this will be returned as part of the response to the client in the location header as a URI. In addition, the server again, depending on where it stored the object, must retrieve or generate a new e-tag for the new object, and this will be returned in the response payload via the e-tag header. Further to this, in storing the object on the server side, if the act of storing the object results in a modification to the object on the server, say for example a last updated timestamp is updated in the object, you may optionally write this post server side updated object in the response to, so the client can now know about those changes. Finally, in the response to the client, the server-side custom API must return an appropriate success HP status code, such as 201. And as we're specifically updating an object on the server side, we must include the HP header Oracle Mobile Sync resource type item in the response to. In receiving the response from the server, the client-side SDK will take care of all of the work thereafter of handling the response. There's nothing for the client-side programmer to do in this scenario. For example, the e-tag returned in the response will automatically be appended to the local cached object that was newly created before the original request. Note overall though, the emphasis, however, on the server-side custom API programmer to inspect the request from the client, work out what to do with the new object on the server side, and return an appropriate response with a status code, headers, and an optional payload back to the client. The next scenario we need to consider is when the client has cached an object from the server and an update occurs. So in this example, the client-side programmer through the endpoint API in their native code will retrieve the endpoint, retrieve an existing object from the local cache, and update that object, then save it. Unlike the previous option when creating objects, the endpoint API has a very subtle nuance for the other scenarios of update and delete. This time it will send a put request to MCS, okay, that's kind of expected, with the updated object as a payload. And in addition, note the addition of the if match star header. This header indicates to the server that the client is using the client's wins policy and expects its updated object to overwrite the server's object regardless. In other words, the if match star header says, I don't care as a client what match you find, server, indicated by the star, my update should win. From here, the server-side custom API developer needs to cater for this scenario by first detecting the if match star header and then doing the following with the received object. On receiving the updated object from the client, if the server node code discovers when using the supplied object ID from the request URL that the object with the same ID no longer exists on the server side, so possibly it's been deleted, then in this case the custom API should create the object with that the client just gave it on the server side. Now, like previous, in the create scenario, the object could be stored in the storage API or the database API or some remote service. So in doing so, you will need to retrieve or generate an e-tag and optionally generate a new object ID and return that as part of the response, an e-tag and a location header, back to the client. Alternatively, if the object is found to exist on the server side, in this case you need to override the server-side object with the client-side object, the updated object, and retrieve or generate an e-tag to again return as a HTTP header to the client. However, in this case you do not need to generate an object ID as the object is assumed to exist with the same ID. Also, like previous, in the process of storing the record server side, if the act of storing the object modifies it, you may optionally return the updated server side object as part of the response payload to the client. Finally, a successful 200 series status code needs to be returned as part of the response, so 201 is appropriate. Once again, in doing this on receiving the update from the server, the client-side SDK will take care of all this work thereafter on handling the response. There's really nothing for the client-side programmer to do in this scenario. And again, note the emphasis, however, on the server-side custom API programmer to inspect the request, work out what to do with the new object, and return an appropriate response with a status code, headers, and an optional payload to the client. Now at this point, I think you're starting to get the idea how this all works for each scenario, and you can likely guess what happens for delete. But let's cover off the last scenario, delete, just so you have the full picture. This time in the client, the mobile developer is using the endpoint to retrieve a synced and locally cached object and then issuing a delete on that local object and save. The endpoint API will this time send a HTTP delete from the client source identified through the URI with the object ID. And again, notice the if match star header, which instructs the server the client should win. On a delete, it is not necessary to send the object across the wire, of course. On receiving this, the server-side custom API must again detect the if match star header. In understanding this, that it is a client win scenario, the server will use the object ID passed in the URL to attempt to find the object on the server side and delete the object, wherever it's stored. Now, if the object doesn't exist, this doesn't really matter as it's the same outcome from the client's perspective. This very simple outcome, the server-side custom API will then return a 204 success code, and finally the client will delete the locally cached mobile object. Overall, note that from the mobile client developer's perspective, they're simply creating, updating, or deleting an object on the server, and with a simple save, the client-side SDK takes care of the rest of the work. However, it's up to the server-side developer to write a custom API that understands the scenarios and acts appropriately to the client's needs. Stick with us for the next episode where we're going to discuss the server wins options and those three same scenarios.